Hello chemistry students. Again, this is correction video for ChemQuest 7 about significant figures. And information here about this. So we saw that scientific notation can be a very nice way of getting rid of unnecessary zeros in a number. For example, consider how convenient it is to write the following numbers. There are a whole lot of zeros in the above numbers that are not really needed. As another example, consider the effect of changing units. So again, they're just kind of giving you some here examples. Notice that the zeros in 21,500 meters and 0.00582 meters are not really needed when the units change. Taking these examples into account, we can introduce three general rules. Number one, zeros at the beginning of a number are never significant or important. Number two, zeros at the end of a number are never significant unless, and you'll find out later, and zeros that are between two non-zero numbers are always significant. Therefore, the number 21,500 has three significant figures. Only three of the digits are important: the 2, the 1, and the 5. So again, what we're saying here is this 2, this 1, this 5, those are important. Okay. The number 10,210 has four significant figures because only the 0 at the end is considered not significant. All of the digits in the number 1005 are significant because the zeros are in between two non-zeros. So here, because 1 and 2 and 1 are not zeros, they're important or significant. And this 0 is because of this rule number 3 that says it's in between numbers that aren't 0. This is the same way the 1 and the 5 are significant. And then all three of these zeros, because they're between numbers that are not 0 because of this rule number 3, are also significant. Verify that each of the following numbers contains four significant figures. Circle the digits that are significant. So these are all placeholders, so these are not significant. So the 4, the 1, the 8, the 2, those are my four significant figures in this one. In this one, these zeros at the end are not significant, so it's just the 4, the 9, the 4, and the 1 that are significant in this one. In this one, okay, again, all of these zeros here, those are not significant. The 3, the 2, the 1, those are significant because, again, these are numbers that are not 0, okay? And then this 0 makes for our fourth one because it's between numbers that are not 0. Lastly, the 3 and the 2 are significant because they're not zeros. And then these two zeros that are in between are also significant because of rule number 3, that they're zeros that are between non-zero numbers. So number 2, how many significant figures are in each of the following numbers? And I can't decide if it's better with or without the light, so keep kind of switching here. Okay. So how many significant figures are in each of the following numbers? So here, okay, the 1, the 5, the 4, the 5, those are all significant because they're not zeros. And this 0 also is significant because it's between numbers that are not 0. So this has 1, 2, 3, 4, 5 significant figures. Letter B, the 4 and the 6 are significant. The rest of these are really just placeholders, so they are not significant. So this only has two significant figures. Letter C, the 2, the 4, the 6 are significant because they're not zeros. And this 0 is also significant because it's between numbers that are not 0. So this has four significant figures. Letter D, this 5 is significant because it's not 0. The rest of these are all placeholders, so this only has one significant figure. Letter E, the 3 and the 1 are significant because they're not zeros. And then all of these zeros because they're between numbers that are not 0, are significant. So that gives us 1, 2, 3, 4, 5, 6 significant figures. And letter F, the 1 and the 2 are significant because they're not zeros. These are just placeholders, so they're not, so this only has 2 significant figures. All right, the exception to rule number 2. There's one exception to the second rule. Consider the following measured values. It is 1,200 miles from my town to Atlanta. It is 1,200.0 miles from my town to Atlanta. The quantity 1,200.0 miles is more precise than 1,200 miles. The decimal point in the quantity 1,200.0 miles means that it was measured very precisely, right down to a tenth of a mile. Therefore, the complete version of rule number 2 is as follows. Zeros at the end of a number are not significant unless there is a decimal point in the number. A decimal point anywhere in the number makes zeros at the end of a number significant. So when we look at this example here, again, our 7, our 2, our 9 are significant because they're not zeros. Here's my decimal. So any zero at the end of a number and to the right of a decimal are significant, which makes this one significant as well. So this has 4 sig figs. The rest of these are not because these are just placeholders. So again, not significant because these are at the beginning of the number. This 0 is significant because it is at the end of the number and there is a decimal point in the number. So number 3, verify that each of the following numbers contains 5 significant figures. Circle the digits that are significant. So again, my 3, my 2 are significant, okay, because they're not zeros. This is rule number 3 from the previous page. That 0 is significant because it's between numbers that are not 0. So we're at 3 right now. Now, because of rule number 2 that we just added to here about, okay, decimal points, that makes these 2 significant as well. Here, my 2 significant, okay, and all of these zeros are because they're at the end of my number and there's a decimal. Okay, so this has 1, 2, 3, 4, 5 significant figures. Here, my 2 and 3 are significant because they're not zeros. And all 3 of these zeros because there's a decimal and a 0 to the right of it. In letter D, the 3 and the 2. And now these are placeholders, so they're not significant, but these 3 here at the end are. Number 4, how many significant figures are in each of the following numbers? Okay, so again, I don't like circling them, so I'm going to underline them. So my 2 and my 1 are significant because they're not zeros. This 0 is significant because of rule number 3 that it's between numbers that are not 0. And then these 3 zeros here are because of rule number 2 up here about the fact that there's a decimal and they're to the right of that decimal and at the end of my number. So this has 3 6 significant figures. Letter B, the 2, the 3, the 1 are significant. These zeros between non-zeros are significant because of rule number 3. And then there's no decimal in this one. So these zeros are not significant. They're just placeholders. So this one would have 5 significant figures. Letter C, my 3 is significant because it's not a 0. And then these 2 zeros, because they're to the right of a decimal and at the end of a number, are significant. So this has 3 significant figures. Letter D, the 2, the 4, the 1, those are all significant. And because this and this are not zeros, that makes these 3 zeros in between them significant. This one is not significant because there's no decimal in this number. So there's 1, 2, 3, 4, 5, 6, 7 significant figures in this one. Letter E, 2, 4, 1 are significant because they're not zeros. Rule number 3, because these zeros are between numbers that are not zero. And then because of rule number 2, these also are significant because there's a decimal and these zeros are to the right and at the end of our number. So there are 2, 4, 6, 7 significant figures in this one. Lastly, the 2 and the 1 because they're not zeros. The rest of these zeros here are not significant because they're just placeholders, so this only has 2 significant figures. Rounding numbers. In numerical problems, it is often necessary to round numbers to the appropriate number of significant figures. Consider the following examples in which each number is rounded so that each of them contains 4 significant figures. Study each example and make sure you understand why they were rounded as they were. Right, so 1, 2, 3, 4, that's where I need my 4 significant figures to be, and because this is an 8, that's going to make this go up. So it becomes 4, 2, 0, 1, 0, 0, 0, 0. Here, 1, 2, 3, 4, so I'm going to round that number based on this one. Okay, and because it's a 2, it doesn't change. Here, 1, 2, 3, I'm going to round here. Because this is a 7, I'm going to make it go up, so we get 8, 4. Now, this last one, right, this really only has 2 significant figures right now, and remember, we wanted 4. So I need a decimal and a 0 so that these zeros are significant. So round the following numbers so they contain 3 significant figures, so that means I'm going to round to this position in this one. This is a 7, so it's going to make it go up, so it's going to be 174,000. This one, remember these zeros are not significant, so 1, 2, it's going to be to here. This 2 means this doesn't change, so it's 0.00250. Here, 1, 2, 3, these are just holding our place. This 2 means that just stays the same. And lastly, right now this only has 1 significant figure. I need it to have 3. So I'm going to have to add a decimal. That would give me 2, and 1 more 0 to give me 3. Number 6. Round the following numbers so they contain 4 significant figures. So 1, 2, 3, here's where I'm going to round to. This 4 means it stays the same, so 2, 4, 9, 4, 0, 0. I can't ignore those numbers. They're just not significant, so they become zeros. 1, 2, 3, 4. This is a 2, so it's not going to change. Okay. Letter C. 1, 2, 3, 4. That 9 is going to make that change. So 12, 0, 5, 0, 0, 0, 0. And then remember these are just placeholders, so they're not significant. So 1, 2, 3, 4. That's not going to make that change. 0, 0, 2, 0, 0, 2. Multiplying and dividing. Now, we're going to do this a lot in chemistry, so this rule is important. When you divide 456 by 13, you get 35, big long decimal number. How should we round such a number? The concept of significant figures has the answer. When multiplying and dividing numbers, you need to round your answers to the correct number of significant figures. To round correctly, follow these simple steps. Number 1, count the number of significant figures in each number. Number 2, round your answer to the least number of significant figures. Here's an example. So this top one, right, the 4, the 5, the 6 are significant, so it has 3 sig figs. Here the 1 and the 4 are significant, it has 2. Here's what my calculator gives me when I put this in my calculator. But I need to round to 2 significant figures because this number has 3 and this only has 2. So that means I'm going to round to here, and that 5 is going to make it become 330. Second example, okay? Again, 1, 2, 3 significant figures. 1, 2, 3, 4, and this 0 is significant as well, so that gives me 5. Here's what my calculator gives me, but I need to round it to 5, so to 3, because there's only 3 in the first one. 1, 2, 3. This 7's going to make it go up, so I have 15.8. So, it's up to you. If you like to do this and write out the whole number your calculator gives you and then write it rounded, that's fine. You also can just do it in one step. And I'm just going to do the one step because I'm going to put the calculator right here, and you're going to see what the calculator gives you. Right, so 12.47 times 270. Here's what my calculator gives me. Go back to this. Okay. So 3,366.9. Now, 1, 2, 3, 4, 5 significant figures here. 1, 2, because remember this 0 is not significant. That means my answer can only have 2. So 33,000, or this is going to become, not 33,000, but this is going to become 3,400 because I have to round to my second position. I'm going to round to here. All right, B. So 36,000 divided by 1, 2, 4, 5. So this has 2 significant digits, just the 3 and the 6. The rest are just placeholders. These has 4 significant digits. That means my answer can only have 2. So I have to round to my second spot, which is this 8. So, and that's a 9, so that's going to make it 29. Letter C, 310 times 12. Okay. This has 1, 2, 3, 4 significant figures. This has 2. That means my answer can only have 2. So I'm going to round to here. So it's going to be 3,700. 129.6 divided by 3. So 1, 2, 3, 4 sig figs, 1 sig fig. My answer can only have 1. Means I have to round to this first position. So this 3 means it's going to be 40. 125 times 1.4452. Okay. So I have 3 significant figures and 1, 2, 3, 4, 5 significant figures. That means my answer can only have 3. So I have to round to this position. Okay. So this is going to be 181. Lastly, 6,000 divided by 2.53. So this only has 1 significant digit, and this has 3 significant digits or figures. So I can only have 1 in my answer, so I have to round to here. And that's a 3, so it's just going to be 2,000. All right, rounding to a decimal place. As you will soon discover, sometimes it is necessary to round to a decimal place. Recall the names of the decimal places. Not super important to me, but there they are. If we rounded the above number to the hundreds place, that means that there can be no significant figures to the right of the hundreds place. Thus, 175,400 is the above number rounded to the hundreds place. If we rounded to the tenths place, we would get 175,398.4. If we rounded to the thousands place, we would get 175,000. Round the following numbers to the tens place. So that's right here. So this is going to be 134, 123, 0, 2, 0. Okay. Because we're rounding to the tens place. Letter B. The tens place is right here. So we're going to round to that, so it's just going to be 23,190. We're going to round to the tens place, which is right there, the 3. So that's going to be 440. And the tens place is this 4. So that 8's going to make it go up, so it's going to be 2,950. Right? You did this back in elementary school. Adding and subtracting. Did you know that 30,000 plus 1 does not always equal 30,001? In fact, usually 30,000 plus 1 is 30,000. I know you are finding this hard to believe, but let me explain. Recall that zeros in the number are not always important or significant. Knowing this makes a big difference in how we add and subtract. For example, consider a swimming pool that can hold 30,000 gallons of water. If I fill the pool to the maximum fill line and then go and fill an empty 1-gallon milk jug with water and add it to the pool, do I then have exactly 30,001 gallons of water in the pool? Of course not. I had approximately 30,000 gallons before and after I added the additional gallon, because 30,000 gallons is not a very precise measurement. So we see that sometimes 30,000 plus 1 equals 30,000. Rounding numbers when adding and subtracting is different from multiplying and dividing. In adding and subtracting, you round to the least specific decimal place of any number in the problem. So example number 1, right? The last significant digit is in the hundreds. Here it's in the tens, which means when I add and subtract, my last significant digit that I'm going to round to is in my tens position. Subtracting, it still works the same way. My last significant digit in this number is in the thousands place. Here it's in the tens. That means my last significant digit has to be in the thousands place, and this 2 makes it not change, so it's just 5,000. So now we're going to use those rules to do these. Again, I'm just going to use my calculator because I'm not very good at math in my head. Okay, so my last significant digit is in the hundredths, and here it's in the tenths, so my answer has to be to the tenths, 1 decimal place, so this is going to be 36.8. Okay. My next one, pull it over here like I had been doing. 120,000 plus 420, right? So here's what my calculator gives me. My last significant digit is in my 10,000s, okay, position. Here it's in the tens place. That means that my last significant digit can be in the 10,000s position, right here. So it's going to be 120,000, right? It doesn't, it's one of those things like the pool example. Okay. So here's my last significant digit, here's my last significant digit, okay? So 140,100 minus 1422. So my last significant digit can be in the, right here, okay? So I'm going to round to that, and that's going to make it go up, so it's going to be 138,700, 138,700. 2.24 minus 0.4101. 2 decimals, this one has 4. My answer then can only have 2, so this is going to be 1.83. Last significant digit in the tens, and then I have 2 decimals, so my last significant digit can be in the tens, so it's going to be 14,670. So again, 10 spot, 1 decimal place, so my 10 spot is the last significant digit. This is going to be 440. We don't add and subtract as often in chemistry as we multiply and divide. So the multiplication and division rules are probably really more important. Number 10, the following are problems involving multiplication, dividing, adding, and subtracting. Be careful of the different rules you need to follow. Right? So 245.4 divided by 120. So there's the math. Now, this is multiplication and division, so it's limited by whatever has the fewest. So this has 4 sig figs, this has 2 sig figs, My answer can only have 2, which would mean it's here. So it's going to be 2.0. 12310 plus 23.5. Now this is adding and subtracting. So it's the position of the last significant digit, which is in the tens and then the tenths. So that means I can only round to the tens. So this is going to be 12,330. 31900 divided by 4. So this has 3 significant digits. This has 1. I'm multiplying and dividing, so it's total number, so it can only have 1 significant figure. So this is actually going to be 8,000. Oops, except I divided. Sorry, let's fix that. Times 4. Sorry about that. Okay, still though only 1 significant digit, so it's going to be here. So it's going to be 100,000. Oh, big number here, right? And this has 4 significant figures, 3 6 significant figures. So I can have 4. So 1, 2, 3, 4. That 7's going to make it go up. So I'm going to have 4, 6, 6, 3, 0, 0, 0, 0. Right, so 46,630,000. This is adding and subtracting, so tens place, ones place, so I have to round to my tens. And that 6 is going to make it up, so it's going to be 1390. And then 4129 plus 200. And then again, I'm adding and subtracting, so in the ones place and then the hundreds place, so I have to round to my hundreds. So this is going to be 4,300. So one of the things for significant figures when we take some notes is this is in Google Classroom, or will become available in Google Classroom about significant digits. This has all of those rules on them. So when we take notes, this will kind of simplify your notes because you're going to print this hopefully. If not, you're going to write this in your outline and in your notes, because this has all of those rules for your significant figures. Okay, in one nice spot. So look for that in Google Classroom. Have a great day. Talk to you tomorrow.